So, hello, I'm Jakobs Janos, and today I will share with you my presentation on radionuclides in the marine ecosystems, more specifically the disposal of radioactive wastewater from the Fukushima-Daichi nuclear power plant into the Pacific Ocean. Before we jump into the facts and data, let us first look at what the marine ecosystems are. As it is stated by National Geographic, marine ecosystems are aquatic environments with high levels of dissolved salt. These include the open ocean, the deep sea ocean, and coastal marine ecosystems, each of which have different physical and biological characteristics. So, why did I choose this topic? On the 13th of April this year, 2021, the Japanese government announced that in next year, 2022, they will begin the disposal of 1.25 million tons of Fukushima-Daiichi tritium-present wastewater into the Pacific Ocean. This contemporary topic is very interesting in that way that this problem has been around for a decade. However, only recently the government has settled for this exact way to tackle the problem. Let us first look at the Fukushima-Daiichi accident itself and the reason why such a problem of wastewater exists in the first place. So, a magnitude 9 earthquake and tsunami hit Japan in 2011. The disaster disabled the reactor cooling systems, which led to a meltdown and release of radioactive compounds into the Pacific Ocean. Scientists estimate that the accident released 18 quadrillion becquerels of cesium-137 into the Pacific Ocean, which is a lot. After the accident, melted reactors were being cooled down with 300 tons of water each day. And since the plant was demolished by the tsunami in 2011, the energy company, Tokyo Electric Power Company, or TEPCO, has been collecting this cooling water in tanks on site. Now there is more than 1.25 million tons of this water, and this is why they have decided to release the water into Pacific, because they will run out of space soon. Now let us observe how did this affect the marine environment and ecosystems. TEPCO says that more than a dozen radioactive elements in the wastewater following the accident were disposed in the ocean. The most damaging ones were the cesium-137, strontium-90, and iodine-131. And the living organisms basically identified them if they were a nutrient, so the organism might quickly absorb the radioactive compound into its body like it was food. And these isotopes are not harmful on their own, but however their decay is, because they release radiation. Yeah, so what is radiation? Radiation can destroy living cells, produce gene mutations, and cause cancer. In terms of living organisms, gamma radiation has a potent power to damage various levels of animals, such as genes, proteins, cells, and tissues. Moreover, this might disrupt the energy supply of food chains, and as a result, the health and normality of marine ecosystems. And lastly, radiation causes growth and reproductive problems in a lot of species in marine environments, including planktons and fish and so on. Yeah. So the food chain begins with phytoplankton in the ocean, and the species absorb the radioactive pollutants, as said before, like food, and then they end up as fecal pellets or other particles that settle to the seafloor, and phytoplankton are consumed by larger zooplankton, small fish, or larger species. And as can be seen in the photo, the radionuclides quite easily infiltrate the Pacific Ocean food chain, making the affected organisms even more prone to continuous exposure and further intake of radioactive pollution, because once they're in, the pollution doesn't really get out of them, the bodies, yeah. So now, let us get back to the release of the wastewater. How dangerous is it, and what actually makes it dangerous? So, after the unsalted ocean water to cool the melted reactors is used, the water is then filtrated from all of the highly radioactive compounds like cesium, strontium, and iodine. However, it is impossible to filter out tritium. So scientists concluded that tritium could be separated theoretically, but there is no practical separation technology on an industrial scale. Accordingly, a controlled environmental release is said to be the best way to treat low tritium concentration water, which is the case right here. But what is tritium? Tritium, as a hydrogen isotope, is very closely linked to the hydrogen cycle in the environment. It can be found in all hydrogenated molecules and connected both with water in tissue and an organic material of plants and animals. And this radionuclide is highly mobile in the ocean and all biological processes, hence it is rapidly absorbed into the various cycles of marine ecosystems. And it has a half-life of 12.3 years, which actually means that the oldest barrels containing the wastewater will reach their half-life during the next year. And this is this is the reason why they start to dispose the wastewater next year, because it's a little more safer. Yes. So tritium could and can be found in 3 different chemical forms. It is tritiated-water, which is the most abundant form of tritium in the natural environment and in living organisms. This is also the form in the cooling waters, soon to be disposed into the Pacific. Then there is gaseous tritium, which is released into the atmosphere by nuclear fission. However, it then turns back into treated water as a result of oxidation processes and re-enters the water cycle. And then there is organically bound tritium, which is tritium that is bound to organic matter, and these organic compounds are distributed according to their properties, which explains the distribution of tritium in organism tissues and why animals and different fish actually maintain the tritium inside them for quite a long time. Yeah. So how does tritium affect the organisms? As for the algae, it is taken into with water during photosynthesis, and as for the marine animals, equilibrium is quickly reached between surrounding treated water and water in the organisms due to the respiration osmoregulation process. Yeah, what is interesting is that tritium bioaccumulation is yet to be found in aquatic life along the French coast, where discharges of tritium into the marine environment are done on a daily basis. This discovery leads to the hypothesis that nuclear industry discharges led by the nuclear plant in La Hague are not as dangerous to living organisms as previously thought. Even though the disposed treated water might do some damage to individual organisms, no actual long-term effects on marine ecosystems will occur due to the fact that the majority of the treated water will reconstruct equilibrium with the surrounding ocean water and atmosphere in just a couple of weeks. So what can we conclude? I say that I believe the evidence of this research material shows that tritium in such small amount that is present in the wastewater of Fukushima-Daichi cooling waters will not cause any serious damage to the marine ecosystems. Even though 1 million tons might sound like a lot, it is truly not a lot when considering the small levels of tritium present in the water, with it being diluted and released only after its half-life. I personally have underestimated the impact of such a nuclear disaster, and for this research has shown that nuclear disaster affects basically every part of the marine environment. And one more thing, marine ecosystems are quite resilient to tritium because it disintegrates into the outer ocean environment quite quickly. Yeah. And what have I learned from this scientific essay? First, I learned how broad is the effect of a nuclear disaster. It's quite terrifying, to be honest. Next, I got to know what is tritium and how does it appear in the environment. I think it's very interesting to see such a isotope of hydrogen having such a radioactive problem in the world, but it's natural, and that is what I learned. I learned also how the Japanese government will solve this problem of the surplus wastewater. And lastly, I learned to use Google Slides templates from online. And that is it. Thank you for watching. And Here we can see the references, and yeah, the presentation template was made by Slides Cannonball. Yes, thank you very much.